coffee break out there, but please give the young guys presenting their work a chance and stay here in the room. So we will do as yesterday. This means that the authors of the posters, we're going to give their 2-minute speech. They should line up here in the order that is shown on the app. And please mind that people who are presenting online will not give the pitch. So be there. I mean, even if your pitch is supposed to be in 5 slots, because it might be right now. So please line up.
Please, the presentation on full screen. Control L for the full screen. Okay, thanks.
Okay. Also, if you want to interact with a presenter, you can use the app and send them a message, so then you can meet and talk about the work. Okay, so let's start with the first poster. Hangul fonts datasets, a hierarchical and compositional dataset for investigated learned representations. No, but that's not the one. So we're not following the order in the app?
No.
Okay. Okay. So let's start with this poster. Sorry about that. Towards latent space optimization of GANs using meta learning. Is the presenter here? Okay, so you can go to the center of the stage, and you have 2 minutes.
Okay. Hello, everyone. So the objective with this work was to train a generative adversarial network with limited samples and also being able to produce unseen classes during inference. So in order to do so, we basically combine a meta-learning algorithm that is a reptile with the standard training of a GAN. In addition to the standard architecture of the GAN, we added a mapping network in front of the generator, and then we trained this mapping network in order to optimize the latent space of the GAN. So the reptile algorithms works by basically training a network on a series of tasks, which in our case are the classes of the dataset, and then we optimizing the weights of the network, merging together the weights of the different tasks. So for our training of the GAN, we basically clone the discriminator and the mapping network, train this network on a single task for a series of iterations, and then merge the weights of these 2 networks with their initial parameters. By doing so, during inference, we are able to produce samples belonging to new classes without training the generator weights. And in order to do so, we just train the mapping, do some inference step on the mapping network and the discriminator, update their weights, and then the generator will be able to produce a new class. Of course, we test this with a somewhat simple data set that is NIST or Omniglot, but still we were able to produce like new classes belonging to this data set. For example, for the NIST data set, we trained the network. And, okay, so we trained the network from the number 1 to 8, or actually 0 to 8, and during inference, we were able to produce the number 9. If you have any question, you can find me here.
Okay, thank you. So we're actually following the order, the ID order, not the order in the app. So this is the next poster, Hangul Fonts dataset, a hierarchical and positional dataset for investigating learned representation. No, so next one, towards reconstruction of 3D shapes in a realistic environment. Okay, so 2 minutes again.
Thank you so very much. Hello everyone, welcome back again. So yeah, in this work, we are presenting our second work, which is actually the paper we presented in our first year of my PhD. So actually the title of this project is Towards Reconstruction of 3D Shape from Realistic Environment. What we found in existing literature We found that the existing approaches reconstruct 3D shape from synthetic image, and they are very good for synthetic image, but when we try to test them for realistic image, they fail. For example, if we talk about the CVXNet and occupancy network, these are those like CVXNet is the paper of Google. It's good for synthetic data, but when we try to test them for realistic image, they fail. So what is the reason behind this? Because they are unable to deal with the background. So this was the problem. So what we did, we produced two solutions. The first solution is the base size solution, which is not end-to-end, and as highlighted here on the top right, where we are feeding the real image, and we have a segmenter. We segment the area of the interest, and we apply centering and padding, and we make the image look similar to the synthetic one, and then we feed that pre-processed image to the existing synthetic-based approaches, and then the existing approaches work good for real image. So in comparison, the proposed approach in the second row, where we are presenting our own approach. So this is end-to-end. So what is the difference between this and that one? So here, what we are doing over here, we are passing two images at a time to our model, and we extract two features. So you see the real image and the synthetic image, we have two different feature vectors, and we compare these feature vectors and force our network to produce the common features. So what are the common features? Common features are the features of the object of interest, which is the common in two images. So we feed these common features to the next module, and we extract the 3D shape. We have some results, and which shows that our approach is good for all the considered categories. And here we have another result. If you want, we can discuss it later in more details. Thank you.
Okay, thank you. Next one, large TV data set for partial video copy detection. Is the presenter here? Okay, 2 minutes.
Thank you. So the problem here is partial video detection, and was to detect small videos in a long sequence, possibly modified for some applications. So this problem is used in application like copyright or fake detection or something other. And a key aspect, as in many computer vision problems, is the performance evaluation. So here the goal is to construct a large data set of videos, and the main contribution is to use some machine learning techniques to avoid the human intervention for ground truthing, and so to avoid some error that can be done with the manual annotation. So if you are interested on this part and how we use this in performance evaluation and the protocol we use it for evaluating other partial detecting algorithms, you can ask me.
Thank you. Next one, an intelligent scanning vehicle for waste collection monitoring. Okay, next one. Faster video efficient line joint object detection and tracking.
Hi everyone, I'm Issa Mouawad from Machine Learning Genoa Center and University of Genova. So our work addresses joint detection and tracking, and thanks to the keynote this morning, I don't have to convince you that tracking by detection is not optimal. So we start from a multitask learning paradigm where we can observe two advantages, one related to accuracy and one related to efficiency, and which is the one we focus on more, which is important in the applications such as autonomous driving and robotics. So we extend one of the famous detectors, which is faster RCNN, to address both tasks jointly by simplifying the detector, which is designed for per frame inference, and extending it to video settings. where we use the tracker and the trajectories to simplify the detection. And we learn also embeddings on top of the detector to help the association step. So we perform experiments on Kitty and MOT challenge benchmark, and we demonstrate really nice efficiency speedups. So feel free to reach to talk about this work or our research in general.
Right, thank you. Next poster, medicinal boxes recognition on deep transfer learning augmented reality mobile application. Okay, next one, a strong geometric baseline for CrossView matching of multi-person 3D pose estimation from Multiview images. You have 2 minutes.
Okay, thank you. So good afternoon, ladies and gentlemen. My name is Sam de Haak. I work at Flanders Make, which is a research institute in Belgium. We are focused at the manufacturing industry. And in manufacturing industry, everybody looks the same. They have a blue overall, they have a yellow cap. And so tracking people is difficult using re-ID networks. What we had to do was do 3D pose estimation. So also there, many works now use re-ID networks to recognize a person in one frame in another viewpoint, but that doesn't work, so we have developed a geometry only based on reprojection errors method to do this inferencing. The main takeaway of this is that it's very easy to fool a 2-camera system, but starting from 3 cameras, you really have a good algorithm with a very low false positive rate. So if you're interested in learning more, I will be here in one of the boxes upstairs. Thank you.
Thank you. Next one. Oh, I skipped one, sorry about that. So next one is case study on the use of safe ML approach in training autonomous driving vehicles. Next one is temporal upsampling of LiDAR measurements based on a mono camera. Okay, so you have 2 minutes.
Good afternoon, everyone. My name is Zoltán Rózsa, and I'm from the Machine Perception Laboratory from the Hungarian Institute of Computer Science and Control. And the paper and the topic I will briefly introduce you is temporal upsampling of LiDAR measurements based on a monocamera. So what is the problem and the motivation? So LiDAR sensors, which are frequently used in autonomous driving to measure distances, has much lower measurement frequency than modern cameras equipped to the same vehicle. So we propose a method to temporarily upsample these measurements based on the monocamera images. Yes, the method is based on object and point level tracking on the camera images, and we predict LiDAR frames to time moments where there were no LiDAR frames available, just camera images. And after the tracking of objects and points, virtual camera motion estimation is done, and finally it is corrected by the ego motion, and in this way we got a predicted point cloud, and we outperformed similar methods for LiDAR point cloud prediction, and yeah, we have other advantages too, and if you are interested more about this method, please read the paper or ask me in the poster session. Thank you.
Thank you. Next poster is Standard SIM, a synthetic dataset for retail environments. Okay, next one. Pocket bluff detection dataset based on facial analysis. Okay. center of the stage, 2 minutes.
Hello, my name is Jacob Feinland. I'm here with my team from Binghamton University in the United States, and we're presenting our data set for high-stakes deception detection based on poker using in-the-wild data. So a lot of the existing deception detection data sets rely on stage scenarios. Sometimes people are being instructed to lie, or there's very specific conditions, and so we use in-the-wild data from professional poker tournaments. So we're able to get a lot of different lighting conditions and camera angles, occlusion levels, which is important because when you're practically applying a model trained on this data, you want it to be able to handle all sorts of different conditions. So we created a semi-autonomous system to use OCR to extract text from on-screen from these poker tournament videos, which are very widely available on the internet. And we use template matching to extract the suit. We also extract faces, and we use face recognition to pair, using the names of the player with the on-screen data to pair that with the faces, so we can use that facial expression data. And so we adapted a state-of-the-art Inception v3 model to be a regression model and trained it on this data set. Oh, also we use the hands, the card values with a Monte Carlo simulation to produce the win probability for each bet that a player makes, and we use those as our bluff labels. We were able to achieve a low mean squared error, which suggests that you're able to use our data to find a correlation between the facial expressions and the labels. So we have hope that our data set will be useful for future high-stakes deception detection research. If you have questions, we're in booth 17. Thank you.
Thank you. Next poster. Next poster. Okay, next 2 posters. Let's get back. Memory-guided road segmentation is the presenter here. Okay, so next one. Densification of sparse optical flow using edges information. 2 minutes.
Yes. Hi again. I am Antonio Buemi from ST Microelectronics. In this poster, I presented a system to make more dense a sparse optical flow. Nowadays, most smart cameras provides hardware implementation not only for optical flow extraction, but also for other feature detection, for example, edge. The basic idea of this method is to exploit edge information to make the optical flow more dense. If 2 motion vectors lies near the same line, it's probably a good idea to create artificially a new motion vector along the same line. And this is the basic of our approach. We tested it from different point of view in order to validate the method. And in particular, we used both objective and subjective metrics. You can find more details in the poster and, of course, in the extended paper. Thank you.
Thank you. Next poster is You Can Retouch This, a deep learning approach for detecting image retouching. Okay. So you got 2 minutes.
Hi, my name is Daniel Aumeier from the Digital Business and Software Engineering Department MCI in Innsbruck. So what did we do? We created a data set out of 1,000 race images where we used an emulator to simulate a mobile phone and created 9 different retouched versions of those images for the dataset to detect image manipulations. Then we adapted proposed CNN from Bio and STAM, where the first layer will suppress the image content and we will only learn the image manipulations. Then we conducted several experiments. First, a binary classification the original image versus all of the manipulated ones, where we have, in most cases, accuracy over 96%. Then we conducted a multi-class experiment, where we have an average accuracy of 88%. If you want to use the dataset, you can use the QR code, or the link to the GitHub is in the paper.
Thank you. Next poster, audio distribution detection using outlier detection methods. Okay. 2 minutes.
Yeah, hello everyone. My name is Jan Diers. I'm from Friedrich Schiller University in Jena, Germany, and I would like to introduce to our topic with an example. Let's say you trained a model to classify cats versus dogs, and you deploy that model in a mobile app. Now, a user of your app takes a photo that contains neither a cat nor a dog. So what shall your model do? What you want from your model is that it denies a prediction, since the model must be wrong in any way. But in practice, only few models are able to deny the prediction. So the field of out-of-distribution detection aims to teach models to deny predictions on anomalous inputs. So if you're interested in how we use outlier detection methods in the field of out-of-distribution detection, feel free to get in touch with me. I'm happy to discuss with you. Thank you.
Thank you. Next poster is human action recognition via transformers. Okay, 2 minutes.
Hello, I'm Paolo Spagnolo from the Italian National Research Council. In this work, the goal of this work is human action recognition from video sequences. We have implemented an approach that integrates a 3D backbone for the feature extraction, while for the temporal pooling, we used an approach based on bidirectional encoders representations from transformers. To our knowledge, there are only a few works on human action recognition based on BERT, on a BERT framework, and we have tested this algorithm on several video sequences extracted from 3 public datasets. Results are really encouraging, even if you can see them on the paper. If you are interested in this work, you can check the paper, or you can contact me or my co-authors after the end of the conference. Thanks.
Thank you. So next paper, engagement detection with multitask training in e-learning environments. Okay, next one. Deepfakes have no heart. A simple ePGT-based method to reveal fake videos. Okay, 2 minutes.
Hi everyone, my name is Alessandro D'Amelio, FuseLab, University of Milan. So in this work, we proposed a method for discriminating genuine videos displaying human subjects from videos that have been manipulated using deepfake algorithms. And we do so by exploiting the physiological information. So what we do in practice is we extract physiological information. In particular, we extract the blood volume pulse signal. And then on this signal, we do so by employing the PyVHR package, which is a Python framework that we developed. And we extract BVP signals, blood volume pulse signals, and from these signals, we compute some measures that allow to detect some simple features. And based on this feature, we are able to classify with good accuracy deepfakes from real videos. If you're interested, you can find more details in the paper or in the poster. Thank you.
Thank you. Next poster, distance-based random forest clustering with missing data. Okay, next one. Decontextualized i3D ComNet for ultra-distance runners performance analysis at a glance. Okay, next one. Using random forest distances for outlier detection. Morphological galaxies classification according to Hubble depth sorry about that, I cannot read it, diagram using CNNs. 2 minutes.
Hi, I'm Antonio Rizzo, and I study computer engineering in Trento, also working as a software developer in ViaSoft. I want to present to you the paper I wrote with Pierluigi Mazzera and Cosimo Distante. Basically, we created a convolutional neural network that is capable of classifying galaxies based on the Hubble-Devereux scheme. And yeah, basically this scheme divides galaxies into 6 microclasses. We have elliptical, lenticulars, then spiral intermediate, barred, and then unbarred, also irregulars. Also we have 26 microclasses, and basically we have a suffix numeric or literal. For example, for elliptical, we have a numeric value from 0 to 7, so basically an elliptical A0 is a circle and A7 is an ellipse. For the dataset, we use the Galaxy Zoo dataset. Basically, it's a crowdsourcing project that many people answered some questions about the galaxies they were seeing. And from that, they averaged all the answers and normalized them. So from 0 to 1, each answer. But this dataset is not ideal for to train on. So we basically, I created an algorithm that converts all of these answers into a label, a label. So for example, if we have an answer that says how many spiral arms do you see, that's if it's a yes, many. So basically this is a spiral, not an elliptical. And for basically we get the CNN proposed architecture, and also we fine-tuned some pre-existing model. As the results, we had 78% on the proposed convolutional neural network and 81 for the ResNet 121, the best fine-tuned model. And the use case for this project, basically when a telescope takes an image of a galaxy, it receives it, and the algorithm basically takes the classification, and we have a preliminary classification for this galaxy. Thank you. If you have any questions, you can find me later.
Thank you. Next paper, frame-wise action recognition training framework for skeleton-based anomaly behavior detection. Next one, untrimmed action anticipation. Center of the stage, you have 2 minutes.
Hi everyone, my name is Ivan Rodin. I'm from University of Catania, and I'm presenting a paper, Untrimmed Action Anticipation. Classical action anticipation task consists of predicting the unobserved future action from a short video sequence sampled 1 second before the beginning of the action. And this task gained much popularity in research community after the introduction of Epic Kitchen's dataset. However, we believe that this problem formulation has some limitations when applying it to real-world scenario. So in particular, for this scenario, we need to know in advance where to sample our video. So it should be exactly 1 second before, which is not really suitable for real-world application. Then also the models trained for the classical action anticipation task may produce a lot of false positives while working on long untrimmed videos. And also such models do not have the opportunity to predict multiple future class labels, which is relevant for the fine-grained activity datasets as Epic Kitchens. To overcome this limitation, we introduced the untrimmed action anticipation task. So we propose to generate multiple future class labels along with the time to action estimates and to evaluate them in untrimmed manner, like every 0.25 seconds. We propose to use mean average precision as an evaluation metric for the task, and we perform 2 types of experiments for this task. So first, we have a series of controlled experiments to justify the selection of the metric. So we randomly change some we do some perturbations and add some noise to the ground truth annotations to show that the mean average precision is a good metric to to capture the quality of the model. And then we performed some experiments by adapting the models trained on trimmed task to the untrimmed task. So long story short, our experiments show that the research needs more investigations. So although the models adapted from trimmed version can perform well, but they still have some limitations. So if you want to discuss this, please feel free to reach me out. Thank you.
Thank you. Next work is SVB classifier, single viewpoint, cloud data classifier with multiview hallucination. Okay, 2 minutes.
Hello everyone, I'm Saber from Italian Institute of Technology, and today I'm going to present you a recent work called SVP classifier, a multiview data classifier, for, a single view data classifier with multiview hallucination. Okay, the problem was that, 3D data get increasing research attention in the last few years, and there are some work that process directly point cloud data, sorry, as the input of the network. But the problem here is that they just get the complete scene information of the object, and they do somehow the pre-processing of the data set. But in the real world, we have to deal with a partial point cloud data which contains self-occlusion. And this damaged the accuracy of the network, of the baseline network. To address this, we proposed SVP classifier, where we first hallucinate the multiview feature, giving the single view data by a conditional variation autoencoder. Then we apply a multi-level graph convolutional network to aggregate the shape feature extracted by our, let's say, generative model for shape classification. Doing so, we outperformed the best state-of-the-art method and the single view version data set of the ModelNet 40 and ScanObjectNet. If you have any question, I would be happy to answer. Thank you.
Thank you. Next work is user-biased food recognition for health monitoring. Okay. So central stage, 2 minutes.
Thanks. Good afternoon, everybody. I am Maggio, and I'm a PhD student at the University of Catania. I'm going to present user-biased food recognition system in context of our food rec project, which basically aims to study, develop, and evaluate an automatic framework to monitor and track the dietary habits of the people involved in a smoke quitting protocol. For example, it can help a doctor to have a better opinion with respect to the patient behavior, mood changes over time, quitting treatment response, and hence his health needs. So we introduce a new food rec 50 data set that is basically collected during the smoke cessation therapy, including 164 real users. And then we have it's collected using the application, both iOS and Android application. So the data is annotated manually to embed the user information with the image label, and data augmentation is applied to increase the data variability and to to compensate the problem with the underrepresented classes. So different transformation techniques have been applied for this. So we propose a novel deep convolution neural network to recognize the food items and to learn the dietary habits of the users. So basically our proposed study differs from the recognition that happens in the development of the general purpose food recognition in a sense that our study involves the user dietary habits. So basically the proposed network consists of two branches, the food branch and the user branch. The food branch basically learns the visual representation of the food items, and on the other side, the user branch takes into account the user habits by learning the eating weight matrix of the user. So it takes one hot vector as input and is learning 164 users eating weight metrics with the 512 features. So when we change the user input, so the result in the prediction is being changed according to the specific user, according to its habits that is being learned while training with the food branch. So it's an effective approach and it outperforms the result. So thanks for your attention. So if you have a question, you can reach me out upstairs in room number 14. Have a nice day.
Thank you. Next work is a robust and efficient overhead people counting system for retail applications. Okay, next one, experimental results on multimodal deepfake detection.
Thank you. Gianluca Marcialis, University of Cagliari. If some of you were present at the Deepfake Detection Challenge yesterday, you noticed for sure that problem of many deepfake detection systems is the ability of generalization. This is the topic we faced with this paper, where we tried to approach the solution by a multiple classifier systems approach, okay? So we try to investigate if combining appropriately multiple classifier systems, it is possible to improve the generalization ability of deepfake detection algorithm, current deepfake detection algorithm, especially when considering never seen before attacks. So if you are interested in this topic, please get in touch with Sarah Concas, who is connected online just now. Thank you very much.
Thank you. Next work, embodied navigation at the art gallery. Okay, next one. Multiview 3D objects localization from street level scenes. Okay, 2 minutes.
Hi everyone, my name is Javed Ahmed and I'm a PhD student at Istituto Italiano di Tecnologia and also University of Genoa. I'm going to present multi-view 3D object localization from street level scenes. So if you are looking for a solution that you want to find all the objects in a scene and you don't know even how many objects are there in a scene, so either you want to find in outdoor or indoor, so you can look at this solution. So what exactly we are doing is considering crowdsourced images in the streets. So there are many organizations and companies that are providing nowadays, for example, Mapillary. So even you can also upload your own images taken from any scene, and they will provide you instant segmentations. So what you can do is first process is, you can see it step-by-step process. The first step is to have the structure of the scene. So that is a simple sparse reconstruction. And after that, somehow you have to delete or refine the scene, or you have to remove the irrelevant part and only have to find the 3D points wherever the 3D objects are. So what we have done is we only consider the 3D points if we project on the images, and those are inside the bonding boxes of the instances or detections. So after that, you have a quite nice refined scene. And at this moment, you still don't have the labels. So we applied 3D clustering, density-based clustering, and then it provides you the label for each point. So now I guess you get the idea, like you have a label for each point, and that actually one cluster is representing one object. So in this way, you can find even any static objects like lampposts, street lights, signboards, or all these kind of things. So if you want to have more detail, you can go into the project page I have mentioned in the paper also. So we can also discuss in this Zoom. Thank you.
Thank you. The next work is Deepfake. What happened? Deepfake style transfer mixer, a first forensic ballistic study on synthetic images. 2 minutes.
Okay. Good afternoon, I'm Luca Guarnera, and in these 2 minutes I will describe this work called Deepfake style transfer mixture, a first forensic ballistic analysis on deepfake images. Deepfakes are all multimedia contents like image, video, and audio, manipulated by generative models. There are several methods able to define if multimedia content is real or deepfake, and by extracting a unique pattern, it is possible to define the specific generative model used to create the data itself. By analyzing this pattern, it is possible to solve other tasks that have been never addressed by the scientific community, like the forensic ballistics on deepfake images. In this work, we proposed this first study in this field, and in detail, we define how many times multimedia content were manipulated by taking into account the style transfer manipulation. And also, we demonstrate several mathematical properties related on these last attacks. Thank you.
Thank you. The next work, imitation learning for autonomous vehicle driving. How does the representation matter?
Next one.
Okay, next one. Improving multi-view stereo with super resolution. Next one. Multi-view spectral clustering via integrated label and data graph learning. Introducing AV1 codec level video steganography. Okay, 2 minutes.
Hello everyone, I'm Lorenzo and I'm a PhD student from University of Catania, and today I am here to present you our results in information hiding in videos encoded using AV1, which is a novel codec produced by the Alliance for Open Media and is being adopted by Netflix and YouTube for their streaming services. What we do is we alter intra-prediction angles along the compression process. This means that the encoder is able to compensate any visual artifact during the process of encoding the video in AV1. We have focused our experiments on short footages from secure cameras, and this is the case where the method has proved to perform best. I will be here to answer any of your questions in the palchetto I-18, in the box I-18, so I wait you there. Thanks.
Thank you. Next one, relaxation labeling meets guns, solving jigsaw puzzles with missing borders. 2 minutes.
Good afternoon. My name is Marina Koroshiltseva, and I'm from University Ca' Foscari of Venice. And today I will present the work of my research group, Relaxation Labeling Meets GAN, where we propose the method to solve the jigsaw puzzle with the missing borders. Solving a jigsaw puzzle is a challenging mathematical problem that abstracts the range of computational problems where the set of unordered fragments should be organized and their original combination. In its simplest form, a jigsaw puzzle problem consists of reordering the set of square pieces on the 2D grid in order to recover the covariant image. Formally, that means to find a permutation matrix that encodes such reordering. Solving jigsaw puzzle with eroded boundary is a more complex task, and many real-world problems, such as reconstruction of broken archaeological artifacts or recovering shredded documents, it can be seen as the solving puzzle with eroded boundaries. In this particular condition, the puzzle pieces do not align perfectly, and direct match of the patches is unfeasible. Okay, in our previous work, we proposed to tackle the puzzle-solving problem is the problem of finding consistent labeling, and we solved this problem using classical relaxation labeling algorithm coupled with the sync-or-knop matrix balancing approach. In this work, we extend our previous model to the more complex task of solving puzzle with eroded boundaries. Our model is based on three following ideas. First, we repair the eroded edges by generating the band of new pixels all around the given page. To do this, we use the GAN-based image extension technique to extrapolate the image of page in all directions. Thus, we cover the void created by erosion by synthetically generated pixels. Second, we use the reconstructed patches to compute the similarity scores, organize the scores in the matrix of compatibility coefficient. And finally, given compatibility coefficient metrics, we run our relaxation labeling puzzle solver and reconstruct the image. There is some results that demonstrate the feasibility of proposed approach. And if you're interested in this project and have some questions, I will be glad to answer. Thank you very much.
Thank you. So the next paper is Shockbased hybrid fusion for movie genre classification. Okay. 2 minutes.
Hello, everyone. I'm Tian Yu from Eindhoven Technology University. Today, I will present our work about multimodal fusion for movie genre classification. So multimodal methods have shown its superior performance compared with a single modal counterparts for movie genre classification. In our work, our main focus is to investigate efficient methods to learn high-quality representations for video and audio and also multimodal fusion. We also investigate the feasibility to solve real-world scenarios like missing modality as well as out of sync. So if you have more questions, we can have discussion after this presentation. Thank you.
Thank you. So next work is less enable, leveraging deepfakes in more content creation. Next one is fooling a face recognition system with a marker-free label consistent vector attack. Center of the stage in 2 minutes.
Hello everyone, I'm Alessandro Ortiz from the University of Catania. In this work we implemented a label consistent vector attack to a face recognition system so that we are able to fool the face recognition system by introducing just a limited portion of poisoned images in the train set, and so taking control over anyone else's identity in the system. And the interesting thing in this work is that the poisoned samples introduced in the train set cannot be spotted by human visual inspection. So if you're interested in this work or curious about these topics, I invite you to join the poster session and have a nice discussion about it. Thank you very much.
Thank you. So this is the last poster. So this concludes the pitch session, and the session is almost over. You have 5 minutes, and maybe you can discuss your poster. And I would say let's thank all the speakers now. We have 5 minutes time to have a big applause, and thank you for attending the session.